additives are the key to making the final product being good. Good base oils, which we refer to as virgin base oils, are made by vacuum distillation of crude oil and further refining them to either group 1 or group 2 or group 3 base oils. As you go up, the complexity of refining increases, and of course the quality of the finished product is much better. Those are the base oils that are used for making the lubricants. Lubricants in this country are facing a very immense challenge on the illicit trade, and particularly from people counterfeiting the brands of the major lubricant brands. Oil is made, base oils are created here by making the base oil from used oil, and the used oil is cleaned and packaged into packages, and it is passed over as good oil, either directly on the brand of the guy who is doing the recycling, or it is used to counterfeit the brands of the major brands. And this is a very serious matter because the base oil, the finished product made from used oil is very bad. It has the same chemical components as used oil, which include carcinogenic material. Those are polycyclic hydrocarbons, which are formed when the oil is burnt in an engine. These ones are cancer-causing material, which can promote cancer on people who are using the same oil. So it's very dangerous oil to the human health and very dangerous to the environment. This oil, however much additive you put in, it will never give you the performance of good quality oil because, first of all, the base oils that you are using, the recycled base oil you are using, is not consistent in quality. It is not pure. It has a lot of contaminants, some of them including glycols that come from brake fluid and coolants. And glycols and base oils or lubricants don't live together because when the lube oil is contaminated with glycol and is heated, the oil quickly thickens. And that is the typical case that you find with these recycled base oils. Now, when you look at the quality that is specified, we tend to use the API quality standards in this country. We have no way of verifying that the product actually meets the API classification. You can only know if the oil meets the API classification if the owner can give you a certificate showing that he has got a license from API, or if he can actually prove to you that the additive used that is the technology used has been approved by the API. So that's where the problem starts. And you will find that you can get an oil, for example, for a motorbike oil measure with a classification like API SL. Generally, a good quality oil made with the SL classification should give you about 3,000 kilometers in the engine, perhaps even more. But when you use some of the oils on the market, particularly those made from recycled oil, you cannot make 1,000 kilometers. In many cases, you can hardly make 800 kilometers and the oil has thickened. And of course, you cannot predict what you are going to get the next time you buy another can. So that's why we say that even when you see the oil on the oil with a standard on, you have got to be careful and interrogate the source of the oil, interrogate the supplier of the oil, and know that he is actually making it from the quality manufacturer. Because both oils pass the CAPE standard. And of course, one of the big problems we have with the CAPE standards is that they are actually paper standards. They have nothing to do with the performance of the oil. It can be demonstrated, and two qualities of oils having the same classification but different performance. So it is very important that you interrogate that. And it's not just a question of the interrogating the supplier. You should also interrogate the supply chain to make sure that the oil that is reaching you is as how the manufacturer made it right from the beginning, because there is a lot of counterfeit on the way. Yeah. So there is that on the oils, and similarly, we have a problem with the brake fluids, and that is what is very scary in this market, because brake fluid is the life of your vehicle, and if your brakes fails and your vehicle is at a high speed, it will crash and most likely it will kill the people that are in. So it is very important that we are careful about the brake fluid we use. Our CAPE standard specifies minimum .4 brake fluid. We should have a boiling point minimum of 230 degrees. But you can find some of the branded products on the market, boiling point less than 150 degrees, which are actually dangerous even before you use those products. And what is worse is that when you use them in the vehicle, they make the master cylinder seals swell, and when the master cylinder seals swell and start leaking, then there is a danger because that brake fluid system, the brake system is now sucking in air, and air cannot be pumped by a hydraulic system, and therefore you risk having a brake failure. What is even more scaring is that the boiling points are very low, and the significance of the boiling point of a brake fluid is that when you are at high speed and you apply a brake, the brake system becomes so hot, the brake fluid will boil if the boiling temperature is low. That's why we specify a high boiling point for brake fluid. Now, if the brake fluid is around 150, it will boil, it will form a vapor lock, and the brake will fail. And in most cases, the driver dies, and so nobody never knows that the brake was caused by the accident was caused by brake failure, because when the police come and check on that brake system, the brake system is working because the boil has actually collapsed, and the brake is now back to normal working. So that is what happens. What is even worse now is that there are very many people down, perhaps in Kariobangi or so, who are actually making brake fluid, and it's not brake fluid, it's water packed in a can of one of the major companies, and is passed off as genuine brake fluid. And when you talk to people on the streets, they will tell you that, yeah, you only know that it's counterfeit when the brake fails. Of course, you know it was counterfeit. You'll never know that he actually used water. So that is what is a big problem. So overall, what you see on the package is not necessarily the quality that you are getting. It is likely that you might be getting water, you might be getting substandard brake fluid. You make sure that the package is properly sealed. You find out with the supplier, you find out there is integrity, and take a risk when you know that you have checked all those things, because your life is very important. If your brake system is leaking, then you know that the brake fluid that you have used is wrong. And you can know it's leaking when you constantly have to top up brake fluid. If you have a good brake fluid, you should never even top up the brake fluid. You will only need to to change the brake fluid after 2 years, because brake fluid is hygroscopic. It takes water from the atmosphere. And if you stay with it for more than 2 years, most likely the water content will have gone high, and the boiling point of the brake fluid would have gone so low that it becomes risky again, as if it's there, and brake fluid with a low boiling point, and the brake fluid will boil and cause an accident. So my point is that don't just look at the label, find out exactly how this product is made, who is making it, and whether it's a counterfeit, to check whether the seal is proper. Unfortunately, we need to get perhaps government agencies to now look at the way we do our standards and make their standards reflect the performance. We need to improve our surveillance, because if I, as a salesman, go to the field and I'm told these stories, surely the guys of CAPES who are going to the field must be being told these stories many times more than that. So why don't they take any action? And how do these brake fluids coming into the market with a lower boiling point than it is intended to be as per the Kenya Bureau of Standards standard? And on the engine oils, the current way of making standards is more of paperwork, and paper standards, they have no indication of performance. We should get perhaps research universities to start looking at how they can judge the performance of the product before it's put on the market. And of course, with the proper surveillance, then you will protect the safety of the people, the safety of the environment, and the safety of the equipment that you have. Thank you very much. I've finished my presentation.
Okay, thank you, Baraka, for the precise and timely presentation. I'd like now to go over to Mr. Joseph from BASF. Joseph? Thank you. Proceed. If you have any questions, kindly type on the chat box, and then we'll be able to answer after this presentation. Thank you.
Good morning, everyone. My name is Joseph Ndung'u from BASF. Please let me know if you can see my presentation.
Yes, it's visible. Kindly put it on presentation mode.
Yes. So the title. Good morning. So the title of my presentation is Debunking Myths About Coolants. So my name is Joseph Ndung'u. I work for BASF. BASF is a German chemical company headquartered in Ludwigshafen in Germany. At the Ludwigshafen site, which is our headquarters, it's one of the largest integrated chemical sites. We have about 110 production plants in this site where we produce different products. And one of those products that we produce is coolants, fuel additives, and lubricating oil additives. So the three myths that I want to talk about today, number one is coolant dye, how important coolant dye is. And the second one is long life coolant, does it require change? And the third myth is whether all coolants are the same. So let's look at the first myth about the coolant dye. How important is the coolant dye? But before we answer this question, we need to understand what is the function of a coolant. Yeah. So we all drive internal combustion engines. Our vehicles use internal combustion engines. Generators use internal combustion engines. Now, the disadvantage of these engines is that they are very inefficient. A third of all the combustion energy is released to the atmosphere as heat. Yeah, and to do this, you need a very effective liquid that will absorb heat from the engine, take it to the radiator, and at the radiator we have a fan which blows air across the radiator, and therefore, and that way releases the heat into the atmosphere. Now, this requires the coolant to travel an equivalent. It's like in terms of the circulation of the coolant, for it to actually be effective in absorbing all the heat from the engine, it's equivalent to pumping about 150 liters of coolant per minute through the cooling system. And remember, our vehicles only use 4 to 5 liters of coolant. So you can imagine how many times and how quickly the coolant needs to go to the engine and back to the radiator. So water is the best medium for absorbing heat from the engine. However, water has several disadvantages. The first one is when it freezes, it expands. It can damage the cooling system. And when it boils, it generates steam. And you've seen steam from vehicles which are overheating. They can actually, there's a buildup of pressure. The radiator can almost explode. The radiator cap can be blown out of the engine. So water is not suitable because of that. Then biggest problem with water is that it causes corrosion. And corrosion is the number one enemy of the cooling system. It is corrosion which causes vehicles to overheat. Now, for a coolant to perform all those functions very well, it has different components that make up a coolant. First of all, to get your ready mix coolant, you need to take up a concentrate and then you mix with water. So you see, water is very, very important in the cooling system. It would make up between 67% and between 50 and 67% in the finished product. Now, the concentrate makes the balance, either 33% to 50%. Here I'm using our product, which we call glazantine, for this illustration. Now, the coolant concentrate is made up of monoethylene glycol, which is 90%, and then we have additives. These are the performance additives. These are the ones that actually protect your engine. Yeah, and then there's a bit of water in that concentrate. So you take that concentrate and mix with water to get a ready mix coolant. And from this, it is clear that we have not mentioned the coolant anywhere. Yeah, you have a ready mix coolant, you have the concentrate, you have the water. We don't mention the. We don't mention. Okay, sorry. We don't mention the. We don't mention the dye anywhere. So in essence, dye is not important in coolants. Dye is basically used for identification. Sometimes you'll find that the auto manufacturers, let's say Toyota or Mercedes-Benz, they would prefer to have a green or a pink coolant, or any other color that they think is suitable for them. So dye is just for identification, but has no function as far as performance is concerned. And having said that, therefore, the major problem that we see in Kenya is that people rely on coolant color to select the coolant they need to use. We sampled some coolants in the the Duakali mechanics repairing their vehicles. We sampled the fastest moving coolants here. Here you'll find that the fastest moving coolants are the ones which are cheap. So if a coolant is cheap, it has a very good market share. Yeah. So we wanted to know whether these cheap coolants are really coolants. And the easiest way to check whether the coolant is a real one or is a fake coolant is to put nails in the coolant in a test tube, leave it to stay for a week up to a month. If it has no anti-corrosion additives, the ones that you see here, the coolant, the nails will start corroding because basically you're dealing with water. And we said water has a big problem in terms of causing rusting and corrosion. So after a week, there will be corrosion. After a month, the nails will even have dissolved in the coolant. And this is a big problem. That's why you see on our highways a lot of vehicles overheating. Why do they overheat? The corrosion damages the thermostat, it damages the water pump, it damages the radiator cap, and the effect is that you get vehicles overheating. Yeah, so this is a very, very big problem. Picking up from where Baraka was talking about standards enforcement in Kenya, you find that even some of these coolants have a KEBS mark of quality, right? Yeah. So when you're buying your coolant, when you're selecting your coolant, I think you should pay more attention, not to the color, not to the price, but probably the integrity of the company that is selling that coolant. Sometimes you find coolants from what we call companies that you can't even trace their production side, you can't trace their office. So these are in essence briefcase companies, and these are the major contributors of these fake coolants that we have in the market. The number two myth that I wish to debunk is about long life coolant requiring no change. Now, let's assume you have selected a proper coolant. You bought your coolant from a source that you consider them to have quality products. But then during your service, normal servicing of your car, you only change your oil. You don't change any other product. You probably top up your brake fluid, you top up your coolant. Yeah? And the main reason why people do this without considering that coolant can be changed is because of what we call long life coolant. So modern coolants are called long life because they can last for years. Yeah, but it doesn't mean they can last for the entire lifetime of the car. So the recommendation is that you need to change. Even coolants need to be changed. Yeah, and the frequency of change is 3 to 4 years. And the main reason why we change our coolants, why we have to drain our coolants after this period and change them, is because the additives get depleted. We have so many additives. Remember when we talked about the composition of coolant, we did talk about the additives that are there, and these are the active ingredients that actually protect your engine. So we have different types of additives in the coolant. We have borates, nitrates, nitrites, organic acid salts, phosphates, silicates. All these perform different functions. Some of them prevent what we call wet liner cavitation, where the engine can actually develop what we call the wet liner. Yeah, or the water jacket that surrounds the cylinders in an engine can actually get perforated. It can get very tiny microscopic holes because of the coolant you're using. Then you see the fuel and the coolant mixing up, and then your car will overheat. They also prevent rusting and corrosion. Some of them, like borate, provide a stable pH environment of the coolant, because the corrosion inhibitors that are used in the coolant, they need a particular pH. Yeah, they need the coolant to be maintained at a particular pH. So you have products like borates, which are responsible for that. So it basically means that when these additives gets depleted, then your vehicle is at the danger of getting damaged and eventually overheating. So you could be using a good quality coolant, but maybe use it for 10 years without change. So within after 4 years, you're probably exposed to the same dangers as someone who is using plain water or coolant of very low quality. And when that happens, you get rusting and corrosion, and this will eventually lead your vehicle to overheat. So the myth to debunk there is that coolant, just like engine oil, needs to be changed. And the take home rather, that coolants, just like engine oils, need to be changed. But the advantage of coolants is that you can stay up to 3 or 4 years before changing them. But after the 4th year, you really need to change that coolant. Otherwise, it is damaging your vehicle. The third myth that I would like to debunk is that all coolants are the same. Some motorists, some mechanics will tell you a coolant is coolant. It doesn't matter what type of coolant you're using. You're very aware that we have, when it comes to engine oils, we have different grades of engine oils. We have engine oils that go maybe for 3,000 kilometers, other that go for 6,000 kilometers, other that can go even for 10,000 kilometers. And all this depends on the quality of the lubricant and the performance level. So it is the same for coolants. Coolants also have performance levels. And one of the key indicators of the quality of the coolant is what we call approval, OEM approval. And how this happens is that the auto manufacturer sits down with the coolant manufacturer, and the automotive manufacturer specifies the requirements of the coolant to use in the vehicle. The cooling system has a lot of metals, a lot of plastics, different types of materials. So the auto manufacturer will say, I want a coolant that will not affect the elastomers in the cooling systems, the plastics in the cooling systems, the aluminum that I use in the engine block, the solder, the brass, all these things. They want a coolant that will not affect that. So the coolant manufacturer now develops a coolant that can meet those requirements. And after he has developed that, the coolant is subjected to what we call lab test, where here we check the corrosion, the ability of the coolant to prevent corrosion over an extended period of time, the compatibility of the coolant with different materials that are found in the cooling system. Then we go to engine test, where the coolant is put in stationary engines in labs and tested as per international testing standards. And then we go to practical test, where the coolant is put in, let's say, a fleet of vehicles, and these vehicles are driven for about 140,000 kilometers. Then after this, the engine is dismantled, and all the parts which were interacting in the coolant are examined to see if there was any corrosion, if there was any damage like pitting of the surface. Then when all this has happened, that's when they give an approval to the coolant. So the approval is a very expensive exercise. It takes 3 to 5 years. It can cost 3 million euros, and this cost is generally increasing. So the way the coolant market is structured, because of this very high cost of coolant development, so you'll find that we have a few companies in the world which manufacture coolant concentrates, and BASF is one of them. So we manufacture coolant concentrates, and this coolant concentrate is what the oil marketing companies buy from us. They dilute and rebrand to come up with their coolant brands. So there has to be someone then who is willing to spend all this money to ensure that the coolant that you're using in your vehicle will perform, because the coolant is subjected to very, very high temperatures, long period of operation. So you need to be sure that nothing will happen in the engine as a result of using a particular coolant. So one way of checking the quality of the coolant, of course, is to see if it has OEM approvals. Another way of checking coolant quality is we have ASTM. ASTM is American Standards Test Methods Organization. They have come up with test parameters that a coolant should meet, and one of them is called one of the most important test parameters is test that a coolant has to undergo is called the glassware corrosion test, ASTM 1384. So this checks the corrosion of different metals, copper, solder, brass, steel, cast iron, cast aluminum. These are the typical metals you find in your cooling system. The aluminum, the engine block could either be cast iron or aluminum. The radiator is mostly cast aluminium. The water pump, the one that circulates the coolant in the engine, is made from steel. Then you have a lot of, let's say, welding of the cooling system. So you have brass, you have some solder. You could be having some copper, some copper parts in the cooling system. So what ASTM does is to check what is the corrosion levels you get when you use a particular coolant, and they give the maximum allowed corrosion. Yeah. So this in red is for copper, they allow only 10 maximum. For solder, they allow 30. Brass, they allow 10 for cast iron. Cast aluminium is 30. Yeah. Now here is an example of one of our products, Glyxantine G48. So against a maximum of 10, very low corrosion on copper. Against a maximum of 30, very low corrosion on solder. Against a maximum of 30, almost negative, almost zero corrosion on aluminium. So if you subject different coolants to these ASTM standards, they will give you different values here. Yeah, and that basically tells you that coolants are not the same. They have different, just like engine oils, they have different performance parameters, and you can check this from the datasheet of the coolant that you are using. So in summary, this is just as an example. This is our product, Glyxantine, is our brand of a coolant, and it has all these OEM approvals. The company has spent all this, all the money, all the years, all the tests to get some of these OEM approvals, so that when you're using it, you can trust the quality of the product. And a brief summary of Glyxantine. It was the first coolant invented in 1920, and over the years the company has invested money in ensuring that we are up to date in terms of technology, in terms of meeting the new requirements of vehicles. What's happening with the vehicles nowadays, the engines have become smaller, they become hotter, they become more powerful, right? So you need coolants that are really working very hard to keep the engine cool and to prevent it from damage. And that's what Glyxantine has been doing over the years. So thank you very much for your attention. I hope I've kept time.
Thank you so much, Joseph, for that good presentation. It was well detailed and well understood. I've seen a few questions on the chat box, and I'd like just to highlight one or two. Just a moment. The first question is mixing of coolants or brake fluids advisable, or once you use one brand, is it advisable to stick with it for the health of the vehicle? Joseph?
Yes, so I'll take the coolants and then I'll leave Baraka to answer brake fluid. So it's generally not advisable to mix coolants of different technologies. Coolants are manufactured using different technologies. So we have what we call OET coolants. We have what we call hybrid coolants. Yeah. So sometimes when you mix this type of different types of coolants, you can have precipitation taking place. And what precipitation will do, it will block the tubes in the inside the radiator, or even the heating core in the cooling system. Yeah? And then you'll have blockage of the coolant, and the vehicle can overheat. So it is generally not recommended to mix coolants of different technologies. But don't confuse here. You can have a green coolant and a blue coolant. Yet you can mix them because they are from the same technology, right? Never use a color to decide whether to mix or not to mix. It's generally advised, if you're not so sure about the coolant in your vehicle, you can as well drain it, yeah, during your next service, and then you now fill your car with a coolant that you know which make it is, and this is what you can be using all the time for topping up. Thank you.
Okay.
Yeah.
Thank you, Joseph. Baraka, you can proceed with the brake fluid question.
Yeah, as I explained earlier, there are a lot of brake fluids which claim to be .4 on the market, and when you use them, you find that they don't have the right temperature, boiling temperature. You'll find they have a negative effect on the seals. So it is better to stay on the same brand that you have started with. So provided that brand is giving you the service you require, i.e. it has got a high boiling point, It does not cause the seals of your master cylinder to swell and the brake fluid to leak. If you mix with any other brake fluid, you will not know which brake fluid has actually caused your cylinders to swell, master cylinders to swell. You'll not know, in case of an accident, which brake fluid you used that is bad. And as I said, there are a lot of fluids even being passed onto the market, which include water. So you've got to be very careful. And brake fluid is your life. I mean, it's the smallest fluid on your vehicle. It's the cheapest material you put on the vehicle, but it's the most important fluid because it means life or death. I hope I've answered.
Yes, that was clear enough. I'll go to the second question, and this is on brake fluid also. I have a question from Abubakar Kalgo, all the way from MRS in Nigeria. He's asking, how can one identify quality brake fluids?
Well, if like in Kenya, there is a Kenya Bureau of Standard, and if there was proper surveillance, you should actually go with what is written on the package, and you can know which brake fluid that you are going to use. Generally, brake fluids that are recommended for modern vehicles is .4 brake fluid, .3 brake fluids, which had a maximum boiling point of 205, are becoming obsolete. The other thing that you can notice, perhaps that is by trial and error, is when you put the brake fluid in your system, make sure that the brake fluid does not require topping up. The minute your brake fluid requires topping up, then you have used the wrong brake fluid. The best thing to do is at the earliest possible time, go remove that brake fluid and try another one that is claimed to be a better brake fluid. And of course, try to find out the integrity of the supplier, who the supplier is, and you can always check with him whether that brake fluid has a problem, why it would have a problem, because good brake fluid should give you good service. I hope I'm answered.
Okay, that is a good question. The other question is, we have antifreeze coolants that is replacing the usual coolants which you have been used to. What is the difference between the two grades? Joseph?
Yeah. So I think I'll restructure that question again. I guess the person who asked that was asking, what is the difference between tropical coolant and antifreeze coolant, right? Yeah. So we, broadly speaking, we have two types of coolants. We have antifreeze coolant and we have tropical coolant. The main difference is that the two main differences between the two. One of them is that you cannot use a tropical coolant where we have very low temperatures, like countries which experience winters. Yeah, but you can use these coolants in tropical countries like our region, where we generally don't have those low temperatures. But I guess if you went down to South Africa, you might have a challenge using these tropical coolants because they do experience some bit of winter. Now, the tropical coolants have a smaller volume of monoethylene glycol. Remember, the function of monoethylene glycol is to prevent water from freezing. Yeah, so they have the package for anti-corrosion, anti-rust, but they have a small volume for the monoethylene glycol, so which makes them not suitable for very, very low temperatures. Now, on the other hand, antifreeze coolants have a big volume of monoethylene glycol, up to 90% in the concentrate formulation. And that makes them very suitable for areas where the temperatures can go below zero. But again, the antifreeze coolants, because of having a lot of glycol, also can carry more additives, can carry more anti-corrosion additives, anti-foam additives, the additives that protect your engine. So you'll find that OEMs only approve antifreeze coolants, but for tropical coolants, you can have a few approvals, yeah, but generally most OEMs recommend antifreeze coolant for the application. So you can use either. You can use either the antifreeze coolant or the tropical coolant. It basically depends on your type of application. If you want to use a tropical coolant, you have to be sure that it is suitable for heavy duty applications. But for antifreeze coolant, you find that as a rule, it will be suitable for both heavy duty and light duty application. Yep, that's all.
Okay, thank you for that. We have, I think, one more question. Just like it is from David, just like it is with lubricant classification, API and SAE, how are the coolants classified to determine the qualities? Joseph?
Yep. In my presentation, I did show ASTM test methods. Yeah. So there is one ASTM test method, 1384, which measures the corrosion prevention ability of different types of coolants. So from this, you can be able to judge the performance of the coolants based on how well it performs on the ASTM performance testing. But we do not have generally the same as engine oils, because engine oils you have the API, where you have API CD, API CI4, all this. For coolants, it's basically how they perform against the limits that have been set by ASTM. That is one way of classification of performance. But the other way of classifying coolants is whether they are OAT, that organic acid technology, or hybrid technology coolants. That's another type of classification. Then we have the one that I've already talked about, whether it's a tropical coolant or an antifreeze coolant. Yeah. So we do not have very specific or basically one method of classifying coolants. We generally tend to look at their performance levels against the ASTM standards methods, and also their formulations. Here we'll talk about the antifreeze or tropical coolant, or we look at the type of chemistry which has been used. So we have the OAT coolants, we have the hybrid type of coolants. Thank you.
Okay, that is well noted. Any other question? Maybe we'll give the platform to one or two people to maybe unmute their mic and maybe just ask a question. If you have a question, you can just raise your hand, use the raise hand feature, and then you can be able to unmute your mic. Okay. We have Wanjiko Manyara. Wanjiko.
Yeah, thanks. Maybe thanks. Please start with Patrick Ireri.
Okay, Patrick.
Thanks, Wanjiko. Mine is a comment. It's also important to let people know that even if you have the right quality of coolant, if you top up with the normal tap water, you're going to mess up, because the normal tap water contains calcium carbonate and other elements from the ground. So you'll have a good coolant, but which you messed up by adding elements that brought up an issue that will now attack the metals within the engine system.
Wow, so I'm glad I let you go first. I was actually going to ask Joseph to shed some light on the issue of using distilled water for the manufacturing of quality lubricants, because we've gotten that interest in a number of meetings that we've attended. In fact, when we visited one of the plants, that was a key matter of discussion. So thanks, Ireri, for raising it.
Yep. Could I add a comment to that?
By all means.
Okay. Thank you. Now, yes. So the water that we use for coolants must be deionized or distilled. Yeah, it must be soft water, because and why we insist on this is if you use, let's say, tap water, it has dissolved minerals, and you see we have a lot of evaporation of the coolant within the cooling system. So what will happen with these dissolved minerals is that they will coat the cooling parts, let's say the aluminum surfaces in the radiator, and once these aluminum surfaces are coated, it basically means their ability to transfer heat from the coolant to the surrounding air is compromised. Additionally, if the level is very high, maybe it's very, very hard water, these dissolved minerals will precipitate and block the radiator tubes, which tend to be very, very fine tubes. If you visit some of these Juakari mechanics areas, you will see them trying to repair radiators by unblocking, trying to unblock them. So all that blockage of the radiator tubes has been caused by using water that is of that has a lot of dissolved minerals, essentially hard water. Yeah.
So how can consumers differentiate, that coolant that has a can I say, where deionized water has been used? This is always quite an inquiry. In layman's, how do I, when you could go into a gas station or wherever it is that I'm getting my car serviced, and I'm able to know that then this coolant has been manufactured using, deionized water or distilled water?
I think, Baraka, you being the producer of ready-mix coolant, can easily shed light here.
That will depend on the integrity of the manufacturer telling you whether the coolant is made of deionized water or tap water. The other thing is that we have a Kenya Bureau of Standard, and for you to be given that standard, the Bureau of Standards of personnel are supposed to inspect your production process to ensure that they conform to what the standard requires. So again, as I said, it depends on the government agencies to support that. Otherwise, you'll have to depend on the integrity of the supply. Am I
Yes,
clear?
yes, very clear. But I think, okay. Thanks, Baraka, as always. But I think for us, what would be great then to bat back to ourselves is, because the customer trusts that technical persons have gone through the requisite processes to ensure that their products do not damage the machinery, then the onus is on the manufacturers to make sure that they comply, recognizing, Baraka, as surveillance is always, and enforcement is always the weakest link to legality and fidelity of the market, and not just ours. So I think here the challenge is back on the industry association members to then ensure that we promote the principle of self-regulation by making sure that which we sell or avail to customers is one that then can stand the test of a good product that meets the requisite specifications. So Mungai, back to you. I can see two hands up, and I think Marianne's hand was up first.
Okay, we'll start with Marianne, and then Joseph Mwango. Marianne, you can unmute your mic.
Hello, how are you?
Fine, thank you.
I wanted to ask, in terms of the percentages of glycol and deionized water, is it usually indicated in the container? Because when you go to the field, to convince these mechanics that this is the correct coolant, they usually need some affirmation.
Yes. So if I may answer that, yeah. So in essence, maybe one of the myths I should have tried to debunk was about glycol. Glycol is not everything about a coolant. There is this misconception in the market that a coolant with more glycol is better than a coolant with less amount of glycol. Or some people tend to think that glycol is actually the coolant. Yeah. The most important part of a coolant is actually water, because it is water that absorbs the heat from the engine, and water has the highest capacity to absorb heat from the engine. So I would even be more interested in the amount of water in my coolant. Now, after water, the next most important one is the additive package, the one that prevents water from damaging the cooling system. Now, glycol comes in only in terms of what we call freeze protection. Yeah. So, to answer your question directly, from the data sheets, you'll be able to see the amount of glycol that a coolant has. But just like the coolant dye, I think the focus should not be so much on the glycol. It should be on the total performance of the coolant, which is driven mostly by the additive package and the amount of water that it has.
Thank you.
Thank you.
Okay, next question, Joseph Mwango. You can unmute your mic.
Thank you. goes to both Baraka and Joseph. And it's on the aspect of quality of lubricants and the reality of the market requiring becoming more price while still having the need for the quality lubricants, because we've talked about the importance of high quality brake fluid and how high quality lubricant. And Joseph, you've highlighted how approved products can be quite expensive, getting that approval. And there's a lot of information in the Kenya and East Africa at large, where the users are becoming more informed of the need of proper lubricants for their machinery, but then they're becoming more price sensitive. So the question is there a solution to quality meeting price? And secondly, is there anything the industry has, something that can be done by the industry to give the market good quality at a price that is, acceptable to the market? I would imagine that a lot of consumers go for these, if I could call them lubricants, because of the aspect of price. Yeah.
I'll answer first. Yes, you know that we say in lubrication, cheap is expensive. The cheaper the lubricant, the more expensive it is. If you take an oil that gives you a drain interval of 1,000 kilometers and a better quality oil that gives you 3,000 kilometers, the price difference might be 20%, but the one that gives you 3,000 kilometers, your lubrication cost is down to a third of what you would have paid with a lower quality lubricant. The one thing that I mentioned is every manufacturer, every credible manufacturer will try to cut down the cost of production without compromising quality. So again, the integrity of the manufacturer. The second thing would be perhaps we need to now start developing some capacities of assessing the performance of some lubricants. And I don't think it's a very big thing. Someone can get an old Toyota engine, put in and check how best that oil can perform. But the message of quality is a message that not only comes from the authorities, but for us who are marketing to keep talking to people about the value of quality and the benefits of quality. I think that has got to be, right now people are going to farming. One of the products that is badly abused is tractor oil. People should be talking to tractor operators and telling the right lubricant. And perhaps the Ministry of Agriculture should be actually verifying and approving those lubricants. So as I feel that the quality of the oil here is good. We've been talking to the government to remove duty on the raw materials, and that can reduce the cost of the lubricant so that people have access to quality lubricants. But in society, there will be the people who want cheaper and cheaper, and they will never understand. They will never appreciate that. But yeah, it's a message we have got to keep preaching. Joseph, up to you.
Yes. So as far as coolants is concerned, yes, when the country standards were only permitting antifreeze coolants. Remember, antifreeze coolants would be more expensive, and that's because they perform higher. Their performance level is higher, just like we have engine oils of API CI4 being more expensive than API CID because they give you higher performance. Some, let's say, briefcase companies have taken advantage of that, and they had now started just coloring the water and selling it at prices which are lower than market prices for antifreeze coolant. So one of the initiatives, and this was driven by the industry and Piea, was to have KEBS revise the standards for coolants. So this was done. So now KEBS standards, which allow for both antifreeze coolant and tropical coolant. Now, tropical coolant, like I said, has a lower volume of glycol. So that basically means the cost of the tropical coolant will be lower, yeah, without compromising the performance. For the tropical countries, you when freeze protection is not critical, then you can use a tropical coolant. So you get a cost-effective coolant that gives you excellent protection of your engine. But now the people who are looking for very, very cheap products in the market, now they have a product that they can use. So that is one area that we can say we've helped the market to address the challenge of people wanting lower price products. But you can't go so low in price. You have to be also provide the quality, and tropical coolants actually is a perfect solution for that. Then the other thing that our customers need to know is that we have something called the total cost of ownership, or let's say of your vehicle. So if you only interested in very, very cheap products, chances are that you might even get colored water, because colored water will be the cheapest coolant you can get in the market. But then this will damage your cooling system. So you can imagine you've lost your water pump, you've lost your radiator, you've lost your thermostat. These are expensive parts of the vehicle, and to replace them costs you a lot of money and a lot of inconvenience. So if you did the cost analysis, the cost benefit analysis of using a very low quality coolant or a counterfeit coolant or just plain water, you'll find that it's more expensive than using even an antifreeze coolant. So it's just educating our customers that cheap is, at the end of the day, very, very expensive, especially when the quality of the product is not guaranteed. Thank you.
Well, perhaps, Joseph, you should have pointed out what you studied, that Kenya spends more money on a cooling system as if we are a big manufacturer of vehicles. And it's because we are either using water or we are using cheap coolants, which are of very low standard. And at the end of the day, it costs us a lot of money. A radiator should last more than 10 years, but most radiators last almost 3 years. You are lucky. We saw that we are going to import a lot of radiators in this country. That's how we are wasting money. And I think it's something that people need to tell the consumer all the time. Same applies to lubricants. You can get cheap lubricants made from recycled oil. And of course, your engine will pack up. I see a lot of people put it in transmission systems as the scaring of tractors. And they just buy a new Holland, put in recycled oil. After a very short time, it packs up. And the cost of it is, or overhauling it, is millions of shillings. So I don't think it's so much of the cost of the oil. Is a question of also understanding the value of quality. Thank you.
Okay, thank you. Thank you. We'll just answer 2 more questions and then be able to close the session. So we have one question on coolants. Please advise on dyes. A lot of fake coolants contain readily available food dyes and the effect on engine life. Joseph?
Look, like I said, maybe I should have said this about dyes. If you have the proper coolant dye, remember the engine is operating at very, very high temperatures. So there are some spots, we call them hot spots, in the engine where the temperature can even go up above 200 degrees Celsius. And generally the cooling system would be operating at 180, 100 degrees Celsius. So if you use a food dye, I don't think we prepare our foods to those kind of high temperatures. So what will happen is that the dye might break down, the dye might stain the inside of the engine. So you're introducing contamination inside the cooling system. So of course this is not good for the engine. And of course, if you take a coolant and it smells like food, it's obviously a fake coolant. So these guys who are dealing in fake coolants, they have no interest of the motorist at all. They're willing to put anything in those containers and just pack them nicely and sell to unsuspecting motorists. So the thing is, like Baraka said, choose your coolant depending on the integrity of the manufacturer. Right. So someone you can trace, someone you can trust, because if someone is in legitimate business, they have nothing to hide. They'll always go for the good quality products. They'll always want to ensure that their customers, their customers' equipment, vehicles are well protected. So food dye should not even be a topic for discussion. It's basically what these guys who are making counterfeit fake coolants are using, because again, a dye that you use for coolants would be expensive because it's supposed to withstand very, very high temperatures for very long. Yeah, but a food dye, of course, is something that is used for a very short period of time. It's used in the food industry, so I guess it would be very, very cheap. So they want to go for the cheapest thing in the market they can get, just to fool the motorist. Yeah, thank you.
Yeah, well, if I may add, a quick way of checking the dye is if you expose this food dye on UV light, on the sunlight, it's likely to change after perhaps a week or so. That you can know that it's bad, and you can know that the dye itself is not good for withstanding those high temperatures. So that's one way of screening it. Perhaps when Joseph showed a nail test for coolant, and that's what we keep teaching people in the Juakali to screen the coolant they get. They just get a bottle of water, put in, drain it, clean it up, put in 2 nails, and put on coolant, and see whether that coolant will rust within 2 weeks, a week, or a month. If it rusts, then you know that coolant is bad. So those are some of the things we as marketers are teaching people to do, and these nail tests are very simple and very quick to do. Thank you.
Okay. The other question is on the ACA, Anti-Counterfeit Authority. Somebody is asking, how is the Anti-Counterfeit Authority engaging in protecting innocent consumers? Maybe Baraka?
Oh, you want me to take that one?
Wanjiko,
Baraka? Huh? I can see Baraka is smiling there. Yeah, so we engage them, obviously, because they have a very big stake to play in terms of enforcing and ensuring, exactly as they are called, the anti-counterfeit. And anything that it doesn't meet specifications is actually counterfeit and illicit for that matter. So what we do is provide them with requisite information and education and sensitization on what they need to look out for on matters to do with particularly the fuel oils and fuel products. But we also avail intelligence to them for them to then investigate further and ensure that they bring the culprits to book. Funny enough is that this is the agency that actually has worked harder than our primary regulator, if I may say so. And in fact, we really exploited the fact that their law has very high penalties, and they are actually can I say very good and very well equipped, even in terms of the processes that enable them to seek or have visibility within the justice system. We have had a number of cases for a number of the major brands, and quite a number of them have also been adjudicated, can I say, in favor of the legitimate or the complainant who are members. So we have, let me say, very good working relationship with them. We have used their law, especially where there was a gap between the previous Energy Act, which is now the Petroleum Act, on matters to do with fines and penalties and all matters relating to ensuring that there's deterrent in the form of the fines and penalties for persons who want to engage in illicit business. And we continue to engage them. I know they are launching their new strategy. They've just had a change in leadership this week, and we're actually attending it with my colleague Ayuma, just to make sure that we continue with the engagement. But obviously, like with every other regulator, it calls for willingness. It also calls on us to educate, sensitize, and also share intelligence. So again, back to you. Whenever you are suspicious about what you have procured, what is suspect in terms of just the price or unfair competition, we are more than happy to receive that kind of information, and we pass on to the relevant agencies with a lot of confidence. And nothing that has been passed to us actually has been found not to have some form of non-compliance, and the necessary action has been taken. I think I can leave it there, Mungai.
That is
Yes.
Yes.
Calgo has a hand up.
Yes, Calgo. Last question. You unmute your mic.
Good morning, all.
Good morning.
My input in this program is that pertaining the counterfeit product we have circulating around over the world. My advice here is that I employ all the manufacturers. In our packaging, we improve on security, because you buy product today of a lubricant, you throw away the package, but people are there outside hunting for your packaging. But what I'm trying to say is that if all improve on the security of the packaging, I don't think we can have much counterfeit circulating within the business. That's just my contribution.
Very interesting, Mr. Cargo. Can I tell you something? And it's actually the same challenge that we have here. But you know what we also found out is that the very manufacturers of packaging for legitimate business people, they have a side line where they actually manufacture for the underhand world of business, if I may put it that way. So I think, again, it all has to do with integrity and perhaps even just the manufacturers who are legitimate to do additional due diligence to ensure that then those that you're doing business with, particularly those who manufacture the packages, then meet the requisite governance and integrity tenets within the establishments. But good point you've made there.
Yeah, I agree with you that if we took a lot of precaution on the package, it will reduce the amount of counterfeit. We need to also have a process of proper used oil management, because it is the used oil that is used for counterfeiting. And you'll find some of the people who are manufacturing recycled oil in this market are already licensed by NEMA. And you know very well that they are going to use it to make lube oil, which is not even going to meet the standard that the customer requires. So there is that requirement of making sure that the packages, after they have been used, can also be collected. So there are also those basic rules that we need to follow to be able to manage these things. And for the last 10 years, we've been asking for industry regulations, and so that the lubricant industry is regulated. The main problem we have is that the industry is not regulated. I know I've been in the fuel business before, and we had a lot of these counterfeits, but because the fuel industry is properly regulated, there are proper measures of trying to track out the adulterators and so on. That amount of adulteration has really gone down from the time when the industry was liberalized. But in the lubricant industry, the amount of counterfeiting, the amount of cheating, and the amount of risking people's life has gone even higher. And there is nobody in the government who has come up and to say, look, we regulate this industry. We must know who is manufacturing the lubricants. Does he know what he's doing? A lot of these people who manufacture lubricants or who import in lubricants don't even know what they're importing. They're cheated, and they bring in the material and sell it and make a profit. But the damage to the economy, the damage to people's health and the environment is enormous. So I agree with you, Mr. Kago, that we need to also look at the management of the products we use from cradle to grave. Thank you.
Absolutely, Baraka, and a really thumbs up. And you've nailed it, absolutely. One of the things we've done, of course, as an industry association, as you know, Baraka, we worked on those lubricants regulations even before the Petroleum Act 2019 was assented to by the president. And they are now awaiting the signature of the cabinet secretary, the current one. We've engaged and continue to engage with EPRA. We are hoping that, as last week we were promised, that they'll be prioritized for gazettement. That will be the case, so that then we can know who's applied for what, and everyone can be accountable. And it's easier to actually survey the market when you know who's complied with the criteria for licensing and who hasn't. I think the second one, which you have also spoken to and which I agree 100% on, is taking responsibility for our own lubricants once they are drained off. And that is to join the system of compliance that we have created within the industry association, because that's what we do to promote self-regulation, and that system is on the safe waste oil disposal. And the industry has come together through the industry association, Piea, procured a licensed collector and end-to-end, if you can call it, the whole range of collecting and making sure that it ends off as prescribed by the law in terms of managing hazardous waste, so that then we can decrease the incident of that used oil coming back to hunters, because it's then repackaged, as Baraka has said, as virgin lubricant, which doesn't even meet the specifications. So again, is to ensure that then we take responsibility cradle to grave. It doesn't cost much, because then it's a kitty that is contributed for by various players. But if any of us then drops the baton and we are still really trying to encourage everyone to sign up, then the risk of illicit trade continues, and it comes back to actually hunt all of us. No one is protected from it once it is not contained and eliminated altogether. I think the other thing has to do with education and awareness, which is exactly what these forums are about. And we thank you, Baraka and Joseph, for really shedding a lot of light, and for the contributions that have also come from the floor. We try and do these forums on a quarterly basis, and they're never to promote any brand, but to promote education and awareness, and to make sure that we can also learn from each other, to secure and keep our business segments legitimate and competitive as much as possible, and to ensure that then the consumer is serviced as we intend them to be serviced, which is to have products that improve their life and livelihoods with doing little harm to machinery and the environment. Mungai, I think this would be a good place to end, if that's okay with you, because we are already top of the hour. Of course, we encourage you. This is a free forum, but we have training programs that will then go into the nitty-gritty. The persons who have been the key presenters here, like Baraka, who has his whole life, he's a walking, can I say, encyclopedia on these matters. Some of the resource persons that we have in our training programs, and we really encourage you. I think there's nothing worse than ignorance, and I know people always say, oh, it's expensive. Never mind that the prices are highly discounted, but try ignorance and you'll find that your investments will not be worth anything if the persons within the establishments then are not properly educated or trained on all matters to do with lubricants and coolants. And we have competency course that's taking place actually on the 28th. It's a one day, and the details are as broadcasted on the screen by Mungai. For those of you who have dropped your emails on the chat, you will receive this. Please attend it. It's well worth it. Trust me. And I think we have showcased the kind of content that you now be receiving in detail from very experienced captains, if I may call them so, of this segment. So Mungai, unless there's something that I have left out, it would be great to then wrap up. I just spoke to Varun. I don't know if he made it to the session, but if he hasn't, he gave me permission to close out. Varun is a chair of the membership committee, and they are the ones who enable the secretariat to facilitate these forums on a quarterly basis. Mungai?
Okay, maybe just a mention on the Safe Waste Oil Disposal Program workshop, which will be held in the last week of March, and the details will be circulated on email once we firm out the dates. And also we encourage everyone to participate in the training program in the flyer. I'll be able to send the details in the flyer. So
yep, and the Safe Waste Oil Disposal Workshop is actually a free sensitization workshop on how that system of compliance works and how it benefits the segment to ensure that then the used oil does not end up in the wrong hands. Thanks, Mungai, for that reminder.
Okay, thank you.
Wanjiku,
yes. Oh, Varun! I hand over the power to you. That's the
sorry,
chair of
sorry.
the
I got disconnected
committee.
at the wrong time. So
no worries. That's fine. That's fine. That's fine. Go ahead.
In again.
Go ahead.
So I'm sure you complimented the presenters. We were lucky to have such experienced and knowledgeable presenters in Mohammed and Joseph, and the attendance is fantastic. As always, you know, we give it an hour, but this one could have gone on, I'm sure, with lots to discuss. I saw the names of the attendees. They're from far and wide, so your knowledge is being dispersed, Baraka and Joseph. So we thank you, and I hope everybody that participated benefited and enjoyed it, and thanks once again to Alfred and his team as well, and we look forward to the next one. Make sure you join up. Thank you.
Thank you very much.
Thanks, Wajiko Manyara.
Asante sana.
This is your student, Martin.
Oh, ooh, thank you, Martin. Thanks for joining on.
Happy for this. Yes.
Yes.
That's
Asante
good
sana.
information. Okay.
Excellent.
Thank you very much.
Thank you. Bye.
Thank you. Have a good afternoon. Bye-bye.